So this is the finishing off the addition formulae. Some of the questions, if you look at old papers on this, it might say show without using a calculator. More recently, they say show using the formula. But whenever they're asking you to show something, they're normally looking for you to use exact values. So try, if you can, to think back to your exact values, and as best as you can, do it without a calculator. So you should know or should be able to work out exact values for 30, if I'm in degrees here, 30, 45, 60 and 90. So they're the exact values that you should know or be able to derive. So how can we make 15, which is what we want, out of these exact values? Well, 15 is 45 take away 30. So that's what we're going to be using to get to this point here, using the compound angle formulae for sine of A minus B. So sine of A minus B is sine cos minus cos sine. And to get 15, A has to be 45 and B has to be 30. So sine of 45 minus 30 is sine A, so sine 45, cos 30, cos B is cos 30, minus, oopsie, I put an equals there, minus cos A, so cos 45, sine 30. I've missed the B off as well. I'm not very on the ball today, sorry. So the exact values tables that you should, can that fit on? There you go. You can just squeeze them on here. So sine 45 is 1 over root 2. Cos 30 is root 3 over 2. Cos 45 is 1 over root 2. And sine 30 is a half. So I've got root 3 over 2 root 2. Minus 1 over 2 root 2. It's a common denominator, so that leaves me with root 3 minus 1 over 2 root 2. Except it doesn't, because I want it in this form here. And you know, thinking right back to either bit my tongue then. Right back to GCSE or the start of A level, that has a rational denominator, that doesn't, so we need to rationalise the denominator of this. So if I times this by root 2 over 2, which is 1, so I'm not changing the value, hopefully I'm going to end up with this. So root 3 times root 2 is root 6, 1 times root 2 is root 2, root 2 times root 2 is 2, and 2 times 2 is 4. Which is exactly what I want. So use your exact values to work out this and rationalise the denominator if you need to at the end. The second example I want us to do, or set of examples, are ones like this. So given that should be an equals, I'm not sure what I've done there. Given that sine A is equal to minus 3/5, and that A is between 180 and 270, so that's important to note, and that cos B is negative 12/13, and that B is obtuse, which is also important to note, find the values of these here. So, cos of A minus B, so let's look at that one first. Cos of A minus B, so the compound angle formula for cos is cos plus sine. Right, so cos A, I don't know what that is. Cos B, I do know. Sine A, I know what that is. Sine B, not a clue. So we are going to need to do some work to work out what the missing parts are. So I know sine A is minus 3/5. I need to work out cos A. Now, I can either use, well, I can't use it, but the things I know about that link sine and cos, the sine over cos is tan, but I don't know what tan A is, so that's no good to me. I also know sine squared plus cos squared is 1, and that might turn out to be useful. So let's think about that. Sine squared A plus cos squared A is 1. Sine is minus 3/5, so I've got minus 3/5 squared plus cos squared A is 1. So I now know that cos squared A is 1 minus this. So minus 3 squared is 9. 5 squared is 25. So cos squared A is 16/25, and if I root that, A could be plus or minus 4/5. Now it cannot be in the context of this question 2 values at once, so I need to think about which one it is. It says A is between 180 and 270. No, thank you. Sorry, that's one of my kids coming in. What did I say? I've lost my train of thought. Oh, so A is between 180 and 270. And we're looking at cos. So if I draw the cos graph, I can see that between 180 and 270, which is this bit here, the graph is negative. So A is minus 4/5. Okay? Yeah. Then, sorry, cos A is minus 4/5. Right, then if I do the same, so hang on, I've worked out sine A. So now I've worked out cos A, I need to go back and work out sine B. So if I know that cos B is minus 12/13. I know that sine squared A, sorry, I'm on B, plus cos squared B is 1. I don't know what sine squared is. I'm so sorry. My kids are going to bed upstairs, or except they're not. I can hear my husband shouting. My mother-in-law's here. It's bonkers. I can't keep my concentration on. Right, sorry. I know cos B is minus 12/13, which means that is then squared, which is equal to 1. So I then know that sine squared B is 1 minus all of this. So negative 12 squared is 144. No, thank you. I'm sorry. You're going to need to come back later. I'll see you later. So sorry. Over 169, which would be, what's 25. So sine B is positive or negative. You can't see that very well. Positive or negative. Oh my goodness. Right. Sine squared B is 25 over 169. So if I root both sides, sine B is positive or negative 5/13. Apologies. How do I know which one it is? So I look at the sine graph. So here's the sine graph. I know that B is obtuse. So obtuse is between 90 degrees and 180. So it's positive. So sine B is positive 5/13. And now I know sine A and cos A, sine B and cos B, so I can work out cos of A minus B. So cos of A minus B is cos A minus 4/5. Cos B minus 12/13. Plus sine A minus 3/5. Sine B 5/13. And if you work all of that out, you should end up with 33 over 65. Okay. So actually the addition formula bit isn't really that tricky. It's using sine squared plus cos squared, which you already know, to work out the missing bits, and then you plug it all in. So if I go onto a new sheet, hopefully you won't get interrupted, but I'm sure my mother-in-law is about to come in as well. So what do we know so far? We've already worked out that sine A, or they tell us, was minus 3/5. And we worked out that cos A is minus 4/5. It told us in the question that cos B was minus 12/13, and we worked out that sine B was 5/13. So that's what we those are the things we were given, those are the things that we wanted, that we had to work out. And now it's asking us to work out tan of A plus B. So this is the addition formulae for tan. We know that the addition formulae for tan is tan A plus tan B over 1 minus tan A tan B. Except we don't know tan A or tan B or tan A or tan B, but luckily we can work them out from here because tan is sine over cos. So tan A, am I on the page? Is sine A over cos A, which is 3/4. And tan B, I'll put it here, I'll squash it on the end, is sine B over cos B, say minus 5/12. Now we know tan A and tan B, we can pop them into here. So tan A is 3/4 plus tan B, which is negative 5/12 over 1 minus tan A times tan B. And if you worked all of that out, you'd get 16 over 63. Okay, so hopefully that makes sense for part B. And then part C, I'll do here in a different colour. If I can find a different colour. Okay, part C was cosec A minus B. There is no additional subtraction formulae for cosec, except we know that cosec is the reciprocal of sine, so that's the same as 1 over sine A minus B. We do know what sine is, so cosec A minus B is 1 over sine of A minus B, and sine A minus B is sine cos minus cos sine. So it's 1 over sine A, which is minus 3/5, times cos B, which is minus 12/13, minus cos A, which is minus 4/5, times sine B, which is 5/13. And if you worked all of that out, we would get 65 over 56. So hopefully that will make sense. Hopefully, I hope you can follow that through. I'll attach a worksheet and pop some questions in there for you to do, to try questions of that type as well. But apart from that, that's the addition formulae done and dusted. So well done. Another topic learned in lockdown. Good work.